This is the beauty, this is what so fascinates me about lichens. They colour the landscape of Wales. Everywhere you look, the trees are covered in lichens, the rocks are covered in lichens, and they're extraordinarily diverse. If you look at it closely, this is an absolute fairyland, isn't it? Of delights, really. Cup-shaped fungi, branching fungi. 8% of the surface of the land on Earth is apparently dominated by lichens. People forget that. All the tundra areas, they're really important in nutrients and carbon sequestration and so on. They're not this sort of nice thing to stick on your railway, your model railway, which most people use them for, but they're there as important components of the functioning of our planet, our life support systems. And they are so incredibly beautiful, though, you have to admit, looking at them closely.
Yeah. Can you tell us a little bit about why Gilfach is so important for wildlife and plants?
Well, it sits here in the middle of Wales, so it's where all the sort of the northern elements, the southern elements, the eastern and the western elements all come together, but it's also got this most amazing array of different habitats. So we've got rock outcrops, we've got bogs, we've got woodland, we've got heather moorland, you name it. We've even got some really strange habitats created on the old railway line, for example. So that together means that it can support a wide range of wildlife. In fact, some of the most diverse wildlife that I know of anywhere in Wales, quite frankly. Well, lichens are a rather extraordinary composite organism made up of a fungus, or in fact we now think there's at least 2 fungi involved in most of them. A photosynthetic partner, that might be an alga, or it could be a photosynthetic bacteria, that provides the whole organism, this whole complex organism with its sugars and its food. And we now realise there's even bacteria involved in the surface layers. They've only been discovered in the last few weeks, because if you start off with the algal partner and the fungal partner, try and grow them together, in fact nobody's ever managed to succeed, and we now realise it's because a lot more organisms are needed. So we're looking at a whole sort of little miniature ecosystem in each of these little tiny bits of lichen here, maybe half a dozen different organisms all come together.
How are they being used now?
Well, recently they've been used to date when rocks might have become exposed. Boulders might have been washed up a beach in a great storm surge. When did that storm surge happen, we might want to know. And by measuring the size of the lichen colonies and understanding the rate of their growth, we can work out when those boulders were first exposed. So, for example, the map lichen, one of the common lichens here, this bright yellow one you can see on the rock spires here, that grows about 0.5 millimetre a year, so you can work out from the size of the colonies when it first colonised. So that gives you a good idea of dating things. They've also been used in the past to dye wool with. We might think today there are not enough lichens about, people shouldn't be dyeing wool with them, but in the past, before the Industrial Revolution, lichens were much more common, because remember, sulphur dioxide wiped out lichens over most of England at the height of the Industrial Revolution, but now they're coming back, and maybe there might be some scope in the future for dyeing wool with them. One up here, this one called cudbear, for example, they used to collect this in great quantities in Scotland. It'd be scraped off the rocks often with a limpet shell or an old spoon, and then it was fermented with urine. Carts used to go around the streets in Glasgow paying good money first thing in the morning for urine. They always checked the specific gravity of it to make sure you weren't cheating by diluting it down. And then that produced, after about a month, it produced a wonderful intense purple dye, and the wool could be dyed with that without using these rather nasty chemical mordants which we tend to use today. Those mordants make the wool rather harsh. With lichens you get this lovely softness and lustrousness to the wool. If you were to dye the wool in peaty water, which is quite acidic, the wool comes out nice bright red. If you put it into something that is slightly more alkaline, it will dye the wool a nice blue colour. Remember your back to school days in the chemistry? Do you remember litmus? Yeah. It goes red when it's acid and blue when it's alkaline. Litmus comes from lichens, a rather similar compound from lichens, still extracted from lichens. Below us here there's another lichen called crottle, and that produces a wonderful dark brown colour and oranges with wool. So it also gives a nice scent to the wool, and this is the scent of Harris tweed, and a lot of the traditional colours of Harris tweed were derived from lichens.
Can we use them to tell us about pollution, air pollution?
They're very good as indicators. They were certainly some were very sensitive to sulfur dioxide in the past, and they were wiped out instantly. Others were more resistant, and that gave us a good measure of concentrations of sulfur dioxide. Now fortunately we've got rid of the sulfur dioxide. We're left now with nitrogen oxides, which create acid rain. And yes, we can still use lichens, and some lichens like ammonia, and so they're present if there's too much ammonia in the air, say from intensive agriculture. So we are now still using lichens because they're there after all 365 days in the year. And they're there the whole time. They can tell you there was a really bad incident. You might not have been there measuring them at the time, but the lichens were. So they tell us that this sort of integrated, give us this time span of pollution levels.
So continuous sampling, really.
They're a continuous sampling mechanism, yes.
What could lichens do for us in the future?
Well, they've got this amazing array of chemicals in them. Over 700 different sorts of unique acids are present in these lichens. And recently, I've been concerned about one particular sort of lichen called tree lungwort, which has diminished quite dramatically. It hates sulfur dioxide, it doesn't like acid rain, and it's still declining. And 2 years ago it was discovered it contains an enzyme in there which breaks down these badly folded proteins, these prion proteins, the cause of Creutzfeldt-Jakob disease, mad cow disease, and this might well provide us with a cure. They're testing it on mice now to see if it can prevent its development in mice, because we're still, I'm afraid, people are still dying as a result of mad cow disease, having acquired those prions many years ago. And yet a lot of the fungi from which we've derived some of our most important antibiotics, such as penicillin, appear once to have been lichens, and so we ought to be looking in some of their close relatives amongst the lichens to see if we can find some new, more effective antibiotics now.
So antibiotics are very needed as well, aren't they?
Absolutely, and I think they have a huge and important future. After all, we've got over 400 different sorts just on Gilfach Reserve alone. Yeah, there's a lot to look through, a lot to look at.
So what lichens are on this rock?
Well, let's just have a look at the rock. First of all, there isn't any rock, is there? Because it's all lichen. Two different sorts of crockle here, dark crockle, this dark brown one, and a paler one, grey one. This is, I think, a Parmelia saxatilis. They both produce a rather interesting dye with wool. Well, this funny little black crust here you might not even think is alive, but in fact this is a lichen. I was amazed to find this one at Gilfach, because it's only known from probably half a dozen localities in Wales, and it's not common anywhere in Britain. And elsewhere it seems to be on boulders beside lakes where it gets splashed. Birds perch on the boulders and a bit of extra nutrients come in. Here it lives in these little runnels, and I presume the sheep used to like to lay up here, and sheep pee and sheep poo used to leach out and trickle down through here, and so this lichen follows those little trickle lines where a bit of extra nutrients comes into the system. And over here is a very attractive lichen. This is called the blood spot lichen, and you can see why, because it's got these amazing blood coloured fruit bodies. This is the fungus fruiting, creating these little sort of red jam tarts, or the strawberry jam tarts on the surface. This lichen is very much an upland species, and here it's about at the lowest I've ever found it in mid Wales on these rocks here. So, and there's two different sorts, one that's yellow and one that's grey, and we've got both present here. That indicates that they've got different substances in them. The yellow one's got this substance called usnic acid in, which has been shown to be quite a useful antibiotic for some purposes. Lichens have this potentially important use. I think we will find a lot more interesting biologically active substances. They live for hundreds and hundreds of years, and like most plants, when they're faced with a problem, they grow away from that problem. Whereas lichens sit there producing ever more complicated chemicals in order to defend themselves, so they don't grow very swiftly. Instead, they commit their energy and resources into producing these weird chemicals, including antibiotics. And we now realise that a lot of the fungi from which we've derived some of our most important antibiotics were almost certainly once lichens, and so they don't need to be lichens anymore, and they've grown on to things like penicillium, from which we got penicillin.
So they're real biochemical factories.
Very important. 700 different sorts of lichen acids, more than 700 different sorts have already been identified, and for the chemist it's quite difficult to try and create these substances completely new. Much better to try and extract them from the lichen and then see whether they have any biological activity, and then if it does, then maybe you go to all the effort of trying to synthesize them into quantities that we can use.
So Gilfach is also really good for lichens on trees. Could you tell us a bit about the lichens on these trees?
Yes, whilst some lichens can occur on both trees and rocks, there's a whole group of lichens that just specialise in trees. And on a big old oak like this, there might be 60 different sorts of lichens, for example. The bigger and older the tree, often the more lichens you get. And Gilfach's special because it has just this small collection of very ancient trees. In Western Europe as a whole, we've got rid of all these big old trees. The foresters have been very active, they've cleared away ancient decaying trees. We've all got young trees. Lots of lichens can only live on these big ancient trees because they like the shelter provided by the branches above, the crevices that occur in the bark. None of these occur on young trees. So Gilfach's got this special group of lichens, and one in particular, a little black lichen which occurs on this tree. This is probably the best tree in Western Europe, this particular lichen. It's that rare. It's one of these species that the British government has decided it wants to specially look after. And we've now got it on, 4 trees at Gilfach, which is about probably half the Welsh population, and not far off being probably half the British population.
So do we get the same lichens occurring on the trunks as we do on the branches and the twigs?
On young trees, maybe yes, but on these big old trees, it's a completely different sort of lichens occur on the trunks. On the twigs, you get these rather larger, rapid colonising. I would call these the weed species of the lichen world. They appear very rapidly. Within maybe a year of the twig growing, lichens will start to appear. Whereas on the trunks, it might be some species won't colonise a trunk maybe for 100 to 200 years, and that's why these old trees are so special.